Hello students, welcome to the new lecture session. Myself, Shankho Ghosh, Assistant Professor of Automobile Engineering Department at Dr. Sudhir Chandra Sood Degree Engineering College under the JIS group. Today we will discuss on the fifth part of this engine, and this topic is taken from the module number 1, that is engine principles and the fundamentals, and the topic is taken from the subject of automobile engine. This is the third semester diploma students subjects. So students, before starting the today's class, we just recall the previous classes. So in the previous classes we covered the engine's definition, its classification, its various basic components and its nomenclature. And on the last class we discussed the working principle of the engine. And today we'll continue this engine section. So this one is the fifth part of the engine. So student, let's start the today's class on engines part 5. On the last class we will discuss the working principle of the IC engine or internal combustion engine. So we can find out that there are the 4 types of IC engines. One is 4-stroke petrol engine, 4-stroke diesel engine, 2-stroke petrol engine and 2-stroke diesel engine. So in the previous class or the last class we already discussed the working principle of the 4-stroke petrol engine or the SI engine and 4-stroke diesel engine or the CI engine. And now today we'll continue this section or working principle with the 2-stroke engine. So student, let's start with the 2-stroke engine. So as we know, the 4 strokes of the 4-stroke engines are suction, compression, combustion and the exhaust. So these are the 4 strokes. So in between, in this 4 stroke, 2 stroke, that is suction and the exhaust, could be served by the alternative arrangement. In this 2 stroke, that means the suction and the exhaust could be served by the alternative arrangement. Then the 4-stroke engine will become a 2-stroke engine. So here, especially without the movement of the piston, so without the movement of this piston, when there will be a power stroke for each revolution of the crankshaft. In such an arrangement, the power output of the engine can be doubled for the same speed compared to the 4-stroke engine. Based on the concept of Douglas-Clark, Douglas-Clark invented the 2-stroke engine in the year of 1878. So in the year of 1878, Douglas Clark invented the 2-stroke engine. He is just serve the alternate way of the 2-stroke, that is suction and the exhaust stroke. So in this way he modified this 4-stroke engine into the 2-stroke engine. So in this 2-stroke engine, the cycle is completed in one revolution. of the crankshaft. The main difference between the two-stroke and the four-stroke engine is in the method of filling the fresh charge and removing the burnt gases from the cylinder. In the four-stroke engine, these operations are performed by the engine's piston during the suction and the exhaust stroke respectively. In the two-stroke engine, the filling process is accomplished. The filling process is accomplished by the charge compressed in crankcase or by a blower. The induction of the compressed charge, which is moves out the product of the combustion through the exhaust port. Therefore, no separation or no separate piston strokes are required for these two operations. So, in these two strokes are sufficient to complete the cycle. One for the compressing the fresh charge, and the other for expansion or the power stroke. So, students, basically the two-stroke means two-stroke consists of the compression stroke and the power stroke. So it is to be noted that the effective stroke is reduced. As we can see here, this is the simplest two-stroke engine. The air-fuel mixture, is introduced into the crankcase. So in this way, first air fuel mixture is introduced in the crankcase through the spring-loaded valve. Through this spring-loaded valve, when the pressure in the crankcase is reduced due to the upward motion, when the pressure of this crankcase is reduced due to the upward motion of the piston during this compression stroke. After the compression and ignition, expansion takes place in the usual way. After the compression and ignition, expansion stroke or the power stroke takes place in this usual way. So during the expansion stroke, the charge in the crankcase is compressed. During the expansion stroke, the charge in the crankcase is compressed, and near the end of the expansion stroke and near the end of this expansion stroke, the piston uncovered the exhaust port. And the cylinder pressure dropped to atmosphere, as the combustion product which is leaves from the cylinder. And further movement of the pistons uncovered, it's uncovered the transfer port, or the inlet port. So during that time, it's permitting the slightly compressed charge in the crankcase to enter the engine cylinder. The piston top usually has a projection. The engine top has some projection to deflect the charge from the exhaust. to deflect the fresh charge towards the top of the cylinder and preventing the flow through the exhaust port. And this serves the double purpose of the combustion and products from the upper part of the cylinder and preventing the fresh charge from the flowing out directly through the exhaust port. So in this way the two strokes are completed. So as as we know, so students, as all of us know, the four strokes are suction, second one is compression, third one is expansion or the power stroke, and the fourth one is exhaust stroke. So in the year of 1878, Douglas Clark has invented this two-stroke engine which is replaced the four-stroke engine. Here, during the four-stroke engine, the power is produced twice revolution of the crankshaft. Here, power is produced only once crankshaft. So every revolution of the crankshaft, the power is produced. So, and during that time, suction and exhaust, and during that time, suction or exhaust could be served by the alternative arrangement. Here we can see the fresh air fuel mixture. The fresh air fuel mixture is entered. The fresh air fuel mixture is entered into the combustion into the crankcase area via this inlet, via the spring loaded inlet valve, and that time piston moves, and when the fresh air charge induced in the crankcase of the cylinder, the piston moves from BDC to the TDC, and when piston reaches the TDC, the air which is present in the combustion chamber, which is compressed, and the ignition is occurred. So basically this is the suction plus, and this is the suction plus the compression stroke. After complete the compression stroke, there is a huge pressure is occurred in the combustion chamber which moves or push the piston towards the downward, that is, and during that time pistons start to move from TDC to BDC, and that when the piston moves from the TDC to BDC, it compresses the fresh air which is present in the crankcase of the cylinder, and when the piston starting to move downward, after moving the piston from TDC, there is an exhaust port, and during this and through the exhaust port, the combustion products will be exhausted to the atmosphere, and after that the piston continue to move downwards, and it opens the inlet port or the transport port, and through the opening of the inlet port, the compressed air fuel compressed fresh charge, and that time through the intake inlet port, compressed intake fresh charge are introduced in the combustion chamber, and there is a deflector is available in the piston which helps to, and this deflector helps to separate the fresh air and the exhaust gas in the combustion chamber. So and when during that time piston moves from TDC to BDC, just because of the power stroke. So during the power stroke, power stroke, exhaust stroke and the power strokes are occurred simultaneously. So in this way the two strokes engines are operated. Now students, here is the animation of this two stroke engine. As you can see, the pistons first moves from upward movement, and when piston moves to the upward movement, the spring loaded inlet valve is open and the fresh charge and fresh air fuel mixture introduced inside the crankcase area of the cylinder, and after that the piston start to move the downward. It is compressed and it is compressed and it is introduced inside the combustion chamber, and the piston again moves from BDC to the TDC. Then the present air on the combustion chamber compressed and it is ignited. When it is compressed and ignited, then again air fuel mixture is introduced in this crankcase area of the cylinder, and after compression ignition, the spark plug ignited this charge, and there is a huge power is produced, and during that time expansion stroke is start, and when the expansion stroke is start, the piston moves from TDC to the BDC, and when piston moves from TDC to BDC, it first open the exhaust valve, and through the opening of the exhaust valve, the exhaust gas or the product of the combustion emitted to this exhaust valve, and in that time intake charge will be again introduced in the combustion chamber. So in this way, in the every revolution of the crankcase, the power is produced. So this is the working animation of the two-stroke engine. Here there is some basic difference of the SI two-stroke SI and two-stroke CI engine. For the two-stroke SI engine, here we use the spark plug. For SI engine we use spark plug, and in case of the CI engine we use the fuel injectors. These are the only difference. So this is the working animation of the two-stroke petrol or the diesel engines. Now coming to the comparison of the SI and CI engine. SI means spark ignition engine and CI means compression ignition engine. SI engine working cycle is Otto cycle, and in diesel engine the working cycle is diesel cycle. In the SI engine, petrol or gasoline or the high octane fuel is used. In case of CI engine, diesel or the high cetane fuel is used. In the SI engine, high self ignition temperature, it is a high self ignition temperature. In the CI engine, it's a low self ignition temperature. In SI engine, fuel and air introduced as a gaseous mixture in the suction stroke. So in the SI engine, fuel and air introduced as a gaseous mixture, and then it is entered into the combustion chamber during the suction stroke. And in CI engine, fuel is injected directly into the combustion chamber at a high pressure during the end of the compression stroke. In SI engine, carburetor used to provide the mixture. Carburetor is used to provide the mixture, and throttle control the quantity of this mixture which is introduced in the during the suction stroke. And in case of CI engine, injector and the high pressure pump used to supply of fuel, and quantity of fuel which is regulated by the pump. In SI engine, use spark plug. In SI engine, use spark plug for the ignition system. In case of CI engine, self ignition by the compression of air, and which is increased by the temperature and required for the combustion. In the CI engine, the compression ratio lies in between 6 to 10.5, and in SI engine the compression ratio lies in between 14 to 22. In case of SI engine, higher maximum RPM due to the lower weight, and in case of the CI engine, the lower maximum RPM due to the lower weight. In CI engine, maximum efficiency which is lower due to the lower compression ratio, and in CI engine, higher maximum efficiency due to the higher compression ratio. So student, these are the basic difference. In between SI and CI engine. Now coming to the comparison of 4-stroke and 2-stroke engine. In case of 4-stroke engine, 4-stroke of the piston is available. And in case of the 2-stroke engine, only 2 strokes of the pistons are available. In the 4-stroke engine, 2 revolutions of the crankshaft occurs. In case of 2-stroke engine, 1 revolution of crankshaft occurs. In case of 4-stroke engine, 1 power stroke occurred in every 2 revolution. Of this crankshaft, and in case of 2-stroke engine, 1 power stroke is occur in each revolution of the crankshaft. In the 4-stroke engine, heavier flywheel due to non-uniform turning movement. Due to the non-uniform turning movement, heavier flywheel is used, and in case of 2-stroke engine, due to the more uniform turning movement, a lighter flywheel is used. In 4-stroke engine, power produced is less. In 2-stroke engine, twice power is produced compared to the 4-stroke engine. In 4-stroke engine, it is heavy and bulky. In 2-stroke engine, it is light and compact. In 4-stroke engine, it is laser cooling and lubrication requirement. In 2-stroke engine, it is a greater cooling and lubrication requirement. In 4-stroke engine, laser rate of wear and tear, and 2nd-stroke engine, higher rate of wear and tear. In 4-stroke engine, it contains valve and the valve mechanism, and 2-stroke engine contain only the port arrangement. The 4-stroke engine, it is higher initial cost, and in 2-stroke it is a cheaper initial cost. The volumetric efficiency in case of 4-stroke engine is more due to the greater time of induction. And in case of 2-stroke engine, the volumetric efficiency is more due to the lesser time of induction. The thermal efficiency in case of 4-stroke engine is high, and in 2-stroke engine thermal efficiency is low. So students, these are the basic difference in between the 2-stroke and 4-stroke engine. Next is the comparison of EC and IC engine, where EC means external combustion engine and IC means internal combustion engine. In case of EC engine or external combustion engine, combustion of air fuel is occurred outside of the engine cylinder in a boiler, and in IC engine the combustion of air fuel is completed in the inside of the engine cylinder. The engines are running smoothly and silently due to the outside of the combustion in case of external combustion engine, and in case of IC engine or internal combustion engine, it is very noisy and operated engine. Higher ratio of weight and bulk to output due to the presence of the auxiliary apparatus like boiler and the condenser in case of the external combustion engine, and hence it is heavy and cumbersome. In case of the IC engine, it is light and compact, and due to the lower ratio of weight and the bulk to output. The working pressure and temperature inside the engine cylinder is low. Hence, ordinary alloys are used for the manufacturer of the engine cylinder and its part. In case of the IC engine or internal combustion engine, the working pressure and the temperature both inside the engine cylinder, so then due to this it is very much high, and hence special alloy are used. In case of EC engine or external combustion engine, it can be cheaper fuel including the solid fuels, and in case of IC engine, high grade fuels are used with the proper filtration. The efficiency is lie in between the 15 to 20% in case of this external combustion engine, and in case of the IC engine, the efficiency lies in between 35 to 40%. In case of EC or external combustion engine, the higher requirement of water, it is higher requirement of water for dissipation of energy during the cooling system. In case of IC engine, lesser requirement of water. So student, these are the comparison of external combustion engine and the internal combustion engine. Now coming to the discuss on the vertical engine. The vertical engine is the one of the engine which has the vertical stroke of the piston. Means here the pistons have two dead center, that is top dead center when piston moves at the top of the top inside the cylinder, and BDC or bottom dead center, which is the when the piston reaches lowest part of the combustion chamber. So this orientation of the engine is called the vertical engine. Now coming to the merits of this vertical engine. Most of the software can easily take advantage. Most of the software can easily take advantage of this vertical scaling. Number 2, it is less power consumption during multiple servers. Number 3 is the crankcase is at the bottom and stores lubricating oil for the lubrication. So these are the merits of this vertical engine. And what are the demerits of this vertical engine? It requires huge amount of financial investment. Number 2, the primary and the secondary forces causes due to the inertia of the reciprocating parts combine together, and it produces the tensile dynamic stress on the foundation bolts. And number 3 is the vertical vibration to the vehicle chassis frame can be felt by the passenger sitting in the vehicle. So these are the demerits of this vertical engine. Now coming to the horizontal engine. The horizontal engine is one of the engine in which has horizontal stroke of the engine. Here moves in between inner dead center and the outer dead center in replace of the top dead center and the bottom dead center. Now what are the merits of this types of orientation of the engine? The primary and the secondary forces causes due to the inertia of the reciprocating parts combine together and give an impulse to the chassis frame of the vehicle. Number 2, it is much lower cost than the vertical scaling. And number 3, it is highly available. And so these are the merits of this horizontal engine. Now coming to the what are the demerits of this engine? The crankcase cannot be used for storing the lubricating oil for the lubrication. Number 2, software has to handle all the data distribution and parallel process, which is complexity. And number 3, here weight of the piston is carried by the cylinder liner. So this causes excessive wear at the lower side of the piston and the cylinder liner, where the cylinder liner gives support to the pistons. So these are the demerits of this horizontal engine. So students, here we complete your first module, that is engine's principle and the fundamental. So from this topic, the outcomes are you can easily understand about the engine, classify them in a various manner, and you can easily understand the various components of the engine and its nomenclature and the working principles of the IC engine. And you can also compare in between the vertical and horizontal engine. So student, this is the module 1, and from the next day we will study on the next module. So still then, stay at home and stay safe. Thank you so much students.